Thank you everybody for coming here. And now let me tell you about something about how the data is collected to create an impressive dashboard. Firstly, I would like to briefly introduce myself. I'm a data architect at Find here in Belgrade, and I worked for more than 7 years in the banking domain and more than 10 years I calculated almost 20 years maybe with different databases and so data warehouses and so everything like this. So what is the magic of impressive dashboard? It lies not only in its visuals but in the seamless orchestration of the data behind the scenes. You know that you can create anything, you can create great visuals, you can create an impressive something, but we discussed it today, we need our data to be prepared carefully. Because behind every elegant chart lies a robust foundation of data preparation, modeling and validation. And dashboard is only reliable as the data that powers it. And incomplete data can mislead decision making or business users. So we can think of it like a theater performance. The actors on the stage are the visuals, but behind the scenes, an entire backstage crew is data orchestration and everything like this. So now let's dive deeper into the backstage processes that make this magic possible. So what you do in Tableau? You connect some source, maybe not only one, but different sources, I don't know, relational databases, Excel files, XML files, or maybe some IP or some API or anything like this, and then let the magic begin, I think. So let me start from maybe the end. What lies in first of sorry. What is lying directly under Tableau? I think you all know these two schemes, the star schema with the one-dimensional table, with one fact tables where we present the fact data like transactions, orders and something like this, and a set of dimensions, for example, calendar, customers, I don't know, products and so on. But if we go further, we can expand our model to be a little bit more normalized and to create a kind of snowflake. So, which questions that business has can we answer with our platform? How can we do it? So this is what we call a business-driven design. So we can establish these these models of data, but how can we do it? Yes. So we have two approaches. One approach is Ralph Kimball, and I put down some words about it. So the main thing is that it is organized based on business needs. So it's a very fast approach, but we have a data redundancy there and limited flexibility. If we need to create a new model, we just create it. We just create several stars, or I don't know. It's a kind of constellation. I had a very complicated constellation in one bank where we had a lot of models and some different dimensions were the same for different reports, but usually they are, I should say, isolated. And then if we follow this approach after time, we have different issues. So the first one is the complex integration. When we integrate multiple data marts into enterprise-wide view, it is rather challenging. Different reports are based on different values, and earlier or later we get the numbers that are different. It's a fact. I don't know how, but I saw it everywhere where I put. So it's not ideal for operational system because this approach is optimized for analytic queries, but may not be suitable for operational data and operational reporting because we can lack of detailed or transactional data. And we have a risk of oversimplification because the business metrics can be focused on the rather aggregated data, but we don't pay much attention to granularity and we can't dive deeper. So another approach is Inman's approach, and historically it was the first approach when we thoroughly collecting all the data and trying to build a normalized third normal form or maybe even data vault or something like this. So this approach says, so we guarantee if the number is this, I don't know, I'm a bank expert, so I usually have an example of different overdue, different credit limits and so on. So if we know that the overdue of this customer is, if one number says, so this is exactly the exact number. Plus minus diner is not acceptable for us. If we have another methodology of calculating this number, we should put it like another attribute, and we should explain it somewhere in our data model, the difference between two maybe similar, very similar attributes. Because, for example, in the banking, you know, you can calculate your overdues in different ways. For example, FIFO, first in, first out, or LIFO, last in, first out. So the methodologies are quite different. So the design is subject oriented. So we have all the attributes, we have a thorough analysis before we can put everything on its place. So the main disadvantage of this approach is a very long TTM, very long. And the more attributes we have, to add in some other attributes takes more and more time because we need to verify that the new attribute won't match any that exists in our data warehouse, for example, or data lake. It's not matter now. So now we can come to a high level DVH or data lake architecture. So our BI tools, our reports, our Tableau is somewhere here. On the Tableau, the presentation area, which is collected as a set of stars or snowflakes. But to calculate this this presentation or data mapped area, we need to have a calculation area, which is usually designed as a third normal form using Bill Inman's approach. And then the first layer is just source systems, which can provide data in different ways. It can be API, it can be streaming, it can be batch loading, and so on. Then we put all this data in so-called raw model, which is basically repeats the structure of our sources. If we have several sources, we put everything on. And then we can define some procedures that will transformate and, apply some data quality checks, master data management, and so on. So we call it trusted data. The more we move into the right, the more trusted data is. The more aggregated and so on. Yes. So a data model is like an organized library, and we need a lot of some additional data catalogs to provide everything to go well. So if we dive deeper, you can know, I don't know, it's a very rather complicated slide, but I think the concept is quite the same. So here we have business intelligence, here we have different, we have some examples of banking systems, not only banking, you know, but my main principal domain is banking, so my example and so on is referred to banking. And here we just repeat the same structure. It is very important because this step is important because usually we have core systems that are designed for OLTP approach. And when we can collect our data, then we have a workload that is not necessary, not adopted for this source system. So we just copy all the data and work only with these copies. The way to copy I will discuss later. And we have some sandboxes for, I don't know, for ad hoc queries, for machine learning, for everything, for, I don't know, for some development purposes. These sandboxes are usually placed on a different server, on a different environment, because usually we have depersonalized data there. Although here on the main track we have a personalized data and we need to govern this data. Yes, so we need first of all establish which data is crucial, which data may be a commercial secret, which data may be personal data, and so we need to distinguish the rules who can access the data, this data, and which way he or she can do it. Because we have a great opportunity of data leakage. So, as for data options, so we need, of course, we need something ETL or ALT tools to govern, to orchestrate everything. It may be, I don't know, if we are speaking of big data, the rule of thumb now is Apache Spark. Or maybe it can be a classical ETL tool like Informatica in its cloud or even on-premises version. Or it may be NiFi, or if we are speaking of streaming, Kafka and Apache Flink and so on, these tools are our option. And so I have some examples of the tools that are used for building a data lake or DVH or I don't know, lake house for our current purpose is not relevant. So, like a storage, it could be used some relational or not relational databases like Oracle, SQL Server or Cassandra. If we are speaking of cloud, we can use, of course, Snowflake or Azure platform or Amazon. And this is everything that puts our data together. So it's Informatica or Pentaho for extract, transform, load, or DBT, a perfect tool just for transforming step. It can provide, has a very low entrance limit. You need to know only SQL to work with it, and then you can put your data into layers and to transform it. But unfortunately, DBT is not able to collect anything. So you need to put the data on the DBT side, and then it can be transformed. So I like NiFi. Why not? An open source tool with a robust UI interface, although it has very small process steps, very small. I don't know, if you need to change two attributes, you need to do it in 2 steps. So your layout may be very complicated there, but you can group them and anything else. So for streaming processing, I think that you know the main Kafka, Flink and so on. Hadoop is becoming obsolete, but the principles are the same. The S3 provided by Amazon architecturally is more or less the same than Hadoop. Because they have some different architecture, they have different approaches for balancing between nodes and so on, but basically the main thing is that you can store file data, raw data there, both on Hadoop or S3, and you can replicate them between nodes, so you have a high degree of parallelism, which helps you to read, to process your data efficiently, quickly, which is very crucial for if we have a small, technological window. For example, you need all your reports to be done at 9 o'clock of your working day, but you live in a distributed country like China, USA, or maybe Russia, and different shops are closing and giving you all the data in different time. So sometimes you have 2 or 3 hours for everything. So you need to collect everything and so on. So, and of course BI, Jupyter or Python for your machine learning, for your ad hoc queries, Tableau as a main BI, or it's competitive Power BI, which is provided by Microsoft and Azure. So I think that is clear. So the one more slide where I put all the different pictures and I put it on my previous slide, so you can basically see what and where you can use. Yeah. So maybe if we come to cloud, you have heard about the medallion architecture with the so-called bronze, silver and gold zones, where the data, as I mentioned, is more curated, more governed, more trusted as we go from left to right. But basically all the description is the same, the concept is the same. So this is a raw data stage area, this is a data mart area, and sometimes some authors say not only silver, let's start with, or not only gold, let's start with the platinum layer, with the most trusted data. So I think that it's a kind of, marketing, really. It's just a marketing, but the approach are quite the same, because all the authors that are defending this concept say that here you should have your stars, here you should have normal form, normalized data, and here as is. So when I think that I can dive deeper into some details, but are you tired? Do you want to? No? Okay, so let me explain it maybe once again about platinum layer. Yeah, it's called a so-called semantic layer. Its main purpose to serve aggregated data models in sub-seconds time, and the data here is basically transferred from one layer to another. So when our Gandalf says let the magic begin, I can say no, and let me give the word to this person. Maybe someone knows who is it? Oh? Yes, it's Arthur Clarke, and his family famous citation, any sufficiently advanced technology is indistinguishable from magic. So, if you are not tired, let me say some words about data governance. I told you that it's strategic. It should be in our modern architecture, because we need to know which data is collected, how, from which sources it is collected, how it is processed, and who can have access to this data. So the concept leads to a kind of data supermarket, which is announced also by Attila for Tableau, but I know that the concept is more general. You can use the concept of supermarket, data supermarket, not only in your BI side, but when you are working as a data engineer. So, data governance is a framework for managing all the assets and including, but not limited to, data quality, accessibility, and security. It involves defining policies and processes for data handling. And in the big organization, everyone who works with data in this or that way is a part of data governance team, of data governance process. Not only data stewards who manage the data, who mark the data as sensitive or something like this, but every data engineer, every business analyst has its own role, has its own responsibility of how they use this data. So, but this is to establish a robust data governance policy is a long way, I should say, and it takes sometimes years. And now when we build new data warehouses or data lakes, the problems of data governance should be considered on the way, not after then we complete everything, but while we are doing our job. So, and another concept which is similar but rather different for handling the data is data virtualization. So, when you build a classical data lake or warehouse, you copy all the data. You copy it to the raw layer, then you transform it or curate it or something else to the detailed layer, and then you aggregate it and you get your data marts. All this process take a lot of time, and we also have some issues with the freshness, I should say, because usually we do it in the batch mode and only a small part goes to us in a streaming mode. So usually we have data for, I don't know, yesterday, an hour ago, and a couple of minutes ago. But data virtualization concept means that we have some views structure based on our sources. So, and then the picture is quite the same. So we have base views that are querying the data directly from the sources, wherever source you have. Files, NoSQL databases, I don't know, web services, cloud applications, and so on. Then you build a, let's say, foundation layer. Foundation layer, it's also a view, just a view. It's a kind of select something from a set of your base views. So here you can put all your data management and maybe some data quality and maybe some, I don't know, data pages, I don't know. Yes? And then you have a third or maybe fourth layer of your views, and it's just business views. The main domain, the main goal of these business views is to be a source for your Excel, I don't know, Tableau, and so on, to exchange data with other systems. So the concept is rather simple, but of course it has some disadvantages, because when you query the data, you pass all your workload to sources, and you don't know the nature of your sources, and you don't know what are they, OLTP or maybe API, or maybe they are very, very slow, and so on. So you need, in fact, you have something like Apache Spark or MPP or Trino in the middle of this concept. And when you have just to process your workload, to parallelize your workload among sources, among all the data, and to give some workload on your server side. But I didn't see any real projects that use this approach, but I know that, for example, in the Middle East, this concept is rather popular. Unfortunately, I wasn't in Middle East, and I hope I'll have an opportunity to work with them. So that's all. Thank you for your attention. I hope
thanks a lot. We have time only for one question, so if someone can ask.
Do you see lately some solid and good instrument or application for data governance that you mentioned through your slides before? Which is the best for you?
You know, I think that data governance is rather vast field, vast domain, and you have several good tools that serve one role. For example, great expectations for data quality. Mm-hmm. For example, maybe DBT for data lineage. Informatica Claire that can make you a data catalog, or data hub for data catalog. Some of the tools, they incorporate everything, but they are not convenient for business users. For example, I tried to implement Colibra. It was not my decision, but I got stuck. I needed to teach my business users how to use it. Yes, it's a lot of new terms, a lot of new, I don't know, entities there in Colibra. I think that there are more of them than we had in our small storage at that moment. Atacama, another solution, but I didn't took any progress a lot.
Thank you. So it's rather it's better to use some custom tools.
Better to use some custom tools for a specific purpose. But maybe AI will solve some of our problems. So, for example, as we are speaking of data virtualization, one of the leading providers is Denodo. They say that they also have data governance incorporated. But I didn't use, so I can't say.
Okay, guys, thanks a lot. So thanks, Vadim.